Hello and welcome. In this video, we continue with numerical bivariate analysis methods covering covariance and correlation. Suppose we have two quantitative variables x and y, and we have collected data on both of these variables from an underlying population, and we have recorded the data on x as x1, x2 up to xn, and the data on y as y1, y2 up to yn. Then the covariance and correlation are statistical measures to check the degree of linear relationship between x and y. The covariance of x and y being calculated by using the following formula, where now n the sum of xi minus the mean of x times yi minus the mean of y. For instance, compute the covariance of salary and working hours. We have collected data on both of these variables, salary and working hours, from all 10 employees of the company. And we know that the mean of working hours is 8 hours and the mean of the salary is 27,000. In order to calculate the covariance, we need the difference of each observation on working hours minus the mean of working hours, and the difference of the salary minus the mean of the salary. That is a salary minus 27 and working hours minus 8. For instance, if we consider the salary column here and salary minus 27, 8 minus 27 is minus 19, 20 minus 27 is minus 7, 30 minus 27 is 3, and so on. Likewise, if we consider the column for working hours minus 8, 6 minus 8 is minus 2, 8 minus 8 is 0, and so on and so forth. Then what we need is the product of the differences. That's the product of the xi minus mu x times yi minus mu y. That is the product of these two columns. Minus 2 times minus 19 is 38, minus 7 times 0 is 0, 3 times 1 is 3, and so on and so forth. Next, what we do is we find the sum of the last column, which is the sum of xi minus mu x, which is working hours minus 8, and salary minus 27, which becomes 137. Putting this 137 in the formula of the covariance, we get that covariance between x and y, in other words, between working hours and salary, is 135 divided by 10, which is 13.5, which is a positive number. X and y has a direct linear relation if covariance is positive, such as this example here. Since the covariance of salary and working hours is positive, with increase in working hours, the salary is also increasing. X and y has indirect relation if the covariance is negative, and x and y has no linear relation if the covariance is 0. However, the problem with the covariance is that it's not bounded, meaning that the covariance can get as large as plus infinity or as small as minus infinity. And we don't know how large is large enough or how small is small enough to conclude that the linear relation is existing either in direct or indirect form. To remedy that problem, we use instead correlation, which is covariance divided by standard deviation of x times standard deviation of y. Going back to the example of salary and working hours, we already know that the covariance is 13.5, and we know that the standard deviation of working hours is 1.5 and the standard deviation of salary is 12. Hence, the correlation is 13.5 divided by 1.5 times 12, which is 0.75. Remember that the correlation is taking values between -1 and +1, including these two numbers. If correlation is between -1 and 0, that's if correlation is negative, that's an indication of indirect linear relation. If correlation is positive, that is, if correlation is between 1 and 0, that is an indication of a direct linear relation. Of course, if the correlation is 0, there is no linear relation. Based on a rule of thumb, if the correlation is higher than 0.75 or is smaller than -0.75, that linear association is considered to be high. In order to present the percentage of linear association, we use another measure called coefficient of determination, which is a measure giving the percent of variation in y explained by x. R square, which is the coefficient of determination, is nothing but the correlation square For example, the R square, or the coefficient of determination of working hours and salary, is 0.75 square, which is 0.56, or just 56%. That is 56% of variation in salary is being explained by the variation in working hours. Thanks for watching and good learning.